Okay, are we live? We're live from downtown Mill Bay. Oh, excellent one in the middle. Yeah, that looks like a great start.
Yo, he just copied me word for word, bar for bar.
That's what
What are you talking
do you
about?
know secretly that's why this is an official method of teaching, and part of it is that you're as groups. People look over and go, oh, they get a hint. That's fine. That's actually part of the method. Not you, sorry. That's a little frightening when you hear that. Oh, that's interesting. Okay, I want you to stop. Two different methods. I'm going to quickly do both. I'm going to check your work. I'm going to get another one. So it's a good warm up. Some people got right there and then they went sideways. If you do the valence electron method, then you just make the valence electrons. You look for unpaired one. You go, ooh, they connect. And then you just redraw it. So I do want to see your work and keep the lone pairs when you draw it. So that's a perfectly good method. Hydrogen has one valence electron. I see some of you writing 17. Does chlorine have 17 valence electrons? No, it's got 7. And it has no charge, so it has 8 electrons. In this method, you would have a central atom. I'm going to pick chlorine. Oops. I'm going to pick chlorine, hydrogen, draw a bond, -2, we have 6. Hydrogen, no spots for more electrons, it's happy, it's an exception. I can put the 6 electrons then on chlorine, -6, done, same structure. This method is way easier for these, so I encourage you to do it. However, there's going to be one where if you know this method, it's going to work out a little bit better. But until that time, do F2. So erase what you got. Now try the same thing with F2. Oh, there's also spots at the back if you want to erase one if there's not enough room. If you guys don't have enough room, erase one of those.
Yeah, actually.
Do one of those. I'm trying to get more whiteboards here, but they're not going to arrive for a while. And then just hold it up when I ask to see everybody, and then that'll work out well. Finish it off. Like your structure's right. Your work, you didn't minus the 6, and that's just a quibble. 6 on each, but that's just a quibble. That looks good. A quibble. That looks good. Those are looking good. Oh, that looks fantastic. I see lots of good work. And good. Okay, if I can get a look this way, I see most people out there and getting right down to the thing, so I want to get on to the next one. Again, and I'm not going to draw circles anymore, because you can just draw lines. Just make sure to redraw it, because a dot with a line with another dot, if you don't erase them, actually means something else. But you can see, okay, those connect. And it's got an octet. It's got an octet. The last step is always checking that you have an octet. Why did I make an O? And why do I not erase? And so that seemed Nice warm up. If you're doing the other method and you're doing the accounting, remember there's a procedure. So you pick a central atom and then you pick an outer atom, then you bond, minus the bonds. And then put as much as you need to for an octet on the outer atom or atoms. And then put everything else in the central atom if you have any left over. And I'm going to say this method, you're going to get to a question where all of a sudden that method's going to work a little bit better. However, let's see what's next. NH4 plus. Oh, it's already got the accounting on it because we answered a question last day. So, why does it have plus 1, minus 1? Does anybody remember? Pardon? We have one less electron. If you're doing the, someone called it the grabby method because you grab the electrons and make little circuits, so that sounds fine. If you're doing the grabby method, that tells you you need to remove an electron. Okay, but I think you're going too fast. I think we need to mix things up a little bit. Let's find new partners. Okay, find new partners. New partners. Find your new people. New people. Erase what you have and do it. New people.
What if we got the same partner?
Sometimes it does that because when you make enough matches, there's going to be duplicates. That's why in any room of 30 people, at least 3 people will share the same birthday. By chance.
Who shares my birthday?
Yeah, someone might, yes. You can lone wolf it or join any group you like. I don't think it's practically possible.
Would it be stable if it did exist?
No, it would immediately fall apart. It could exist, but it would immediately fall apart. Too much energy. Yes.
Are we still doing NH4?
We're still doing NH4 because I haven't seen all of those.
Stop moving around. I'm gonna get on with this. Obviously.
Okay, for this one, as soon as you're done it, I want you to sit down. So as soon as you got it drawn, it's perfect. You've shown your work, and I can see your work, so not just the final drawing. Have a seat so I can walk along and look at it, because I want to walk along and actually look at these. Who's your partner?
Matthew.
Matthew. Where's Matthew? Where? Oh, you just brought that back. I thought that was your work.
No.
Oh, okay, never mind. I was like, shouldn't the work be following? There you go. It's all good. I need to get some color. Okay. Only quibble I'm going to make is that they all need brackets because they're plus 1 to show that the entire thing is plus 1. The reason I make that quibble is we have compounds like this. Let's make that an H, and let's make that R, and we've got C double on O, and O. And we'll make it another H. And the reason is that there are compounds like this one where they actually have a negative charge and a positive charge, and they belong to different parts of the molecule. Whereas this molecule, the whole thing, you always want to show it has a charge, you always want to put it in brackets. However, you're lazy, you don't want to show the whole bracket, you're allowed to make what's called the pretend bracket. You start making a bracket, and then you give up. It's considered a full bracket. Other than that, good accounting, we got rid of the extra electron, but you did accounting and the other method, so you like full did it. Accounting and then put it in. Don't forget, you put the in 2, 4, 6, 8. If you do that, if for any reason you got it wrong, having all of the accounting helps me give you part marks. But other than that, you're getting the right structure, put in the brackets, good structure. It appeared as if from nowhere. There's no work with that one. I do want to see your work. Good accounting. Good accounting. Excellent. Excellent. Oh no, we have 2 minutes left.
I'm back up.
And we have CO2. You can go as soon as you show me the correct structure for CO2. New groups. Go. Please don't use your hand to erase. Use an eraser. The oils from your hand actually make it harder. If you notice the ink is sticking a lot more, it means too many people are doing this with their hands. Carbon dioxide, CO2, accounting or...
You get a table or it's
Oh, yeah, I'm not just minusing it. Once, okay, here, let's take any atom. Let's say I'm doing this AB2. What's the central atom? A. So let's say it had 10 electrons. I don't know how many it has, but let's say it had 10. A is the central atom. Let's see, so you put B. You always bond one bond each. So then I was minus 2, 4, because I had 2 bonds, and I know I have 6 electrons. And I put what electrons I have left on outer atoms. 1, 2, 3, 4,
CO2,
5,
right?
6. And I would put them on evenly, except I'm going to run out. So minus 6 electrons, and I have 0, and then I can do something else. Okay, I said you could go as soon as you had it, but you can also go when the bell rings. I'm going to take pictures, and then we will revisit that next day. You have way too many electrons. That is, you're not doing the accounting